As you may know, GPIO pins can be set as both inputs and outputs on HID Remapper mappings. When set as inputs, they can be used for connecting external buttons or switches, and when set as outputs, they can, among other things, be used for driving LEDs. Let's make a words per minute meter for our keyboard using HID Remapper and some LEDs. I have connected 8 LEDs to the GPIO pins on my Raspberry Pi Pico that I'm using as my HID Remapper. And I made it so that the faster I type, the more LEDs turn on, like on an audio amplifier or something like that. Let's start slowly. And let's go faster. Okay, let me show you the HID Remapper configuration that I used to make it happen. There are 8 mappings. Each is responsible for turning one of the LEDs on or off. Each LED is controlled by one register. When the value in the register is 1, the LED is on, and when it is 0, the LED is off. And these are just the GPIO pins that I have my LEDs wired to. Okay, let's see the expressions that set the values in these registers. Let's start with expression 2. As you can see, it fetches the value from register 9. We are setting it in expression 1, which I will get to in a second. Then we check if the value in register 9 is greater than 1. If it is, we set register 1 to 1. Then we check if it's greater than 2. And if it is, then we set register 2 to 1, and so on. So register 9 controls the number of LEDs that will be on at any given moment. Let's check out expression 1 that sets the value in register 9. As you can see, it's pretty long. First it fetches the current value from register 9. Then it does the same thing for all the keys on the keyboard, or at least all the alphanumeric keys. It fetches the current state of the key, whether it's pressed or not. Then it fetches the previous state of the key. Then it compares the two values. That's what the GT does. The only time that this condition will be true is when the current state of the key is pressed and the previous state of the key is not pressed, meaning that it has just been pressed this frame. We get either a 1 or a 0, depending on whether that key has just been pressed, and we add that value to the current value of register 9. And we do this for all the keys. After all of this, the value from register 9 will be incremented by the number of keys that were pressed this frame. Okay, but we don't want this counter to keep building up to infinity. We want it to be some kind of running average of your typing speed. So every frame we multiply it by 0.999. This makes it so that when we stop typing, the value in register 9 will slowly fade back to 0 and all the LEDs will be off. Finally, we put that value back into register 9. Okay, and that is it. I think it's a cool trick and all it requires is a few LEDs and resistors. Leave a comment if you have any questions. Thanks for watching.